Hey y'all, I really messed up during fifth period last week, so I have taken upon myself to put some clarifying notes in Blend for you, and hopefully this will help fifth period. If somebody else is lost, hopefully this will help you. There are pretty much only three things you need to understand about polynomials for this test. You need to know how to factor them. You need to how to correctly write the end behavior, and you need to be able to write the zeros. Also, I apologize. I just realized I haven't put together the Quizlet for you. I promise that will be up no later than Thursday at 4:30, probably sooner. I won't send a remind text to let you know when it's up. But I think y'all needed, I promise you, the Quizlet on end behavior, because that's weird. Okay, so here we go. Okay, in front of you, you have three functions. All three of these functions, or graphs, however you want to think about it, are cubic functions. That is, they have an x cubed in them. I only changed a few things about them. In the center here, you see something that is referred to as the parent function. It is called the parent function because it is the function that from which if you add or subtract from it, it moves the graph around somehow. And if you look at the two on either side of it, the one on the left is less bumpy than the one on the far right. But all three have the same end behavior. And end behavior seems to be what a lot of you are struggling with the most. Some of you are having issues understanding what is meant by end behavior, and some of you are having trouble with the notation. So I'm going to take these three graphs to talk about the end behavior. No matter what kind of cubic function you have, if the very first term, or the one with the largest degree, which is cubed, is positive, then you will have exactly the same end behavior going up on the right and going down on the left. And that has to be written, as x goes to the right, y goes up. As x goes to the left, y goes down. Some of you are having issues with this because you're having trouble looking at what's happening at the ends. We are looking specifically at the very end. We're looking at what direction that's going. We're looking at that and pretending it just keeps going forever and ever. Well, it actually does, and this one just keeps going on forever. We're looking at the direction of the arrow. Your x's are going to the right, your y's are going up. Your x's are going to the left, your y's are going down. Your x's are going to the right, your y's are going up. Your x's are going down. Your x's are going to the left, your y's are going down. Here, your x's are going to the right, your y's are going up. It's pretty steep, but I think you should still be able to make sense of it. Okay, so now we're going to mess around with these functions a little bit. The nice thing about this video is that I can work through this fairly quickly without having to draw it for you every time, so I can talk about a lot of graphs at once. So we're going to take advantage of this video to do just that. Okay, on this slide you can see the parent function and two other, like, I messed around with it, tried to figure out what would happen functions. So in the center, I don't see much difference. I don't know about you, but I do see that the end behavior is the same, where as I go to the right with my x's, I'm going up with my y's. As I'm going left with my x's, I'm going down with my y's. And that's all you can really get out of that. So you have to know how to write in this way. As x goes right, y goes up. I should have written as in front of that. Sorry about that. As x goes to the left, y goes down. Okay, if you look at the third one, that's where things, this is where people think too much. Okay, so on your homework it said something about how many bumps or something like that. I don't care about that. I just care about the zeros. Because if you can see the zeros there, which hopefully you can, you know what I'm talking about hopefully you know what I'm talking about when I'm talking about zeros. I'm talking about where it crosses the x-axis. Now, those look like two little eyes. And if you look over here, it crosses only once. But on the other one, it bounces. And that's important because that tells you something about your zeros. And I tried to talk about this in all of my classes. On that first one, that crosses once at -1. That means that one of your factors must be x plus 1. Again, that's because one of your zeros is -1. Because when x equals -1, x plus 1 equals 0. And y'all are having a hard time putting the pieces together there, and that's pretty normal. And I'll talk about that more on Thursday, or in the case of first and second period, I will not talk about that again, but I have faith in you. If you have questions, please let me know. Text me or something, even if it's during class. I'll be in class too, but I'd rather talk to you than listen to, I don't know. I think I'm going to be stuck with a bunch of elementary school teachers, and it's going to be hard to ask Algebra 2 questions amongst a bunch of elementary school teachers. Okay, so here we have it bouncing on 1. That means that 2 of your factors are x minus 1. So that means that when x equals 1, x minus 1 equals 0. And that also means that this whole thing, just using the graph, we can figure out what the equation is. But we're not used to doing that. There's only one on your homework where you're expected, or on your review, or no, it was your homework, where you were expected to do that. And that was number 10 on the homework that was either due Tuesday or Monday, depending on which class you were in. So we're going to look at the original function, y equals x cubed minus x squared minus x minus 1. And I'm going to factor that. What goes into the first two? X squared. You're left with x minus 1. What goes into the next two? Negative. You're left with x plus 1. Uh-oh. These don't match, do they? That tells us something. That tells us that there's another way to go about doing this. And I tried to talk about this in class, and I'm going to go through it very, very, very quickly because you do not need to know this for the test. Okay, I don't want you to focus on this too much because, again, you're not going to be tested on this. I did make a pretty weird error in copying this from my computer. This should be a plus way up here, and down here this should be a plus, which makes my factoring wrong, but I still factored by dividing. So factoring by division is a possibility, and that was the only thing I was trying to bring up during fifth period. You do not need to do this for the test. I cannot emphasize that enough. All you need to do, again, for this particular test is to be able to factor, find the roots, and describe the end behavior. That's it. Even though I've tried to talk about what's going on with the graph, and that's important background information for you to be able to check whether or not you're right. And it's not completely useless. I'm not teaching it to you because it's not important. I just want you to understand that you can do this entire thing just by being able to factor and understand that end behavior notation. So we're going to go through some graphs real quick. Okay, so in front of you, you have some normal looking graphs, some kooky looking graphs. This first one on the left is just y equals x cubed. All I did on the second one was I changed that sign in front of the x cubed to a negative, and it made it flip. That will be important to notice. That is it right now, other than the fact that that changes the end behavior. You should be able to look at that graph and see that the end behavior is different. Then we get over to these x to the fifth graphs. Now we know, or I taught you, you may not know it, because all of us space out sometimes, that means that there's a max of 5 zeros. Now, that doesn't mean there have to be. That means there's a max of 5 zeros. But this one on the left has only one. It has some really funky looking things going on in it. However, the one below, I'm having issues with my computer right now. Okay, if you look at the one below, you can see that that actually does cross the graph 5 times. And you should be able to see that it crosses at -3. So that means one of your factors is x plus 3. Because if you replace x with -3, -3 plus 3 is 0. Another one of your factors is -2. X plus 2 is another factor. X plus 1 is another one, because it's crossing at -1. Then you have another 0. I'm trying to get this thing to move so I can zoom. There we go. Then we have another 0 at positive 1. So one of your factors is x minus 1. And the last one is at positive 2. So your last factor is x minus 2. Hopefully that's not off the screen. So just looking at the graph, knowing what those zeros are, you should be able to find the zeros. I will probably only put 1 on there like that. But you really need to understand end behavior, so I'm going to do the end behavior very quickly on these. I need to change my color real quick. You might not need it, but I do. Okay, so here on the left, I keep talking to you like you can see where I'm zooming. As x goes to the left, y goes down. As x goes to the right, y goes up. But on this second one, as x goes to the right, y goes down. As x goes to the left, y goes up. You've got to just straight up memorize what all that gibberish means. I know it's unusual notation, but I also know that you can handle it. On this one, the third one, as x goes to the left, y goes down. As x goes to the right, y goes up. And that notation is really critical. On the bottom right, as x goes to the, this is where some of you had a lot of trouble with this, so I might as well start talking about this right now. So your graph is going through like up, down, up, right? So a lot of you had trouble. Actually, I think it was mostly towns. But anyway, just throw him under the bus. Why don't I? As x goes to the left, y goes down here. And as x goes to the right, y goes up. So you have to use a little imagination when the whole graph doesn't show up, but you can pretty much see the pattern. And you can tell where it's going at the far ends, where those arrows are headed. And that is your biggest issue right there, understanding that. So you need to know how to factor. You need to know how to set those factors equal to 0 so that you can find the zeros. So, oops, that's too small, isn't it? Set the factors equal to 0. To find the roots or zeros. And that's why they are two different signs. If you look here on the far right, sorry, turd bunnies. Okay, this means we have a 0 at -3. This means we have a 0 at -2, etc. Always opposite signs, because you're setting each of these factors equal to 0 and solving. Got it? Sorry this was so long. I've never made such a long video. Ugh. Take care. Good luck. Don't be afraid to text me, even if it's in the middle of class. I am concerned, but I will see B-Day kids on Thursday, and your test will be on Tuesday. A-Day kids, I will see you on Wednesday when you have your test. I will be in after school on Thursday for tutoring. I will be in before school on Tuesday and Wednesday for tutoring. Y'all take care. Bye.